Force and Laws of Motion. Part 5. Law of Conservation of Momentum. In the previous video, we learned about the third law of motion. In this video, we will learn about the law of conservation of momentum. Just like any other conservation law of physics, the law of conservation of momentum tells us that the total momentum of a system is always conserved provided no other external unbalanced force acts on the system. Let us consider an example to understand this statement. Consider two balls A and B having masses ma and mb such that they are traveling in the same direction along a straight line with velocities ua and ub respectively. Also, let us suppose that no external force is acting on these two balls. Let the velocity of ball A be greater than the velocity of ball B, such that the two balls collide with each other after some time. During the time of collision, which, say, lasts for a time period t, the ball A exerts a force FAB on the ball B. Similarly, the ball B exerts a force FBA on the ball A. Again, let us suppose the velocities of the objects A and B after collision are VA and VB respectively. Now, from the definition of momentum, we can say that the momentum of ball A before and after the collision is ma ua and ma va respectively. Then the rate of change of momentum of ball A, which is equal to FAB, which is equal to P2A minus P1A divided by T during the collision will be ma multiplied by Va minus Ua divided by T. In the same way, we can say the rate of change of momentum of ball B, which is equal to FBA, which is equal to P2B minus P1B divided by T during the collision to be MB multiplied by VB minus UB divided by T. Now, according to the third law of motion, the force FAB exerted by ball A on ball B should be equal in magnitude and opposite in direction to the force FBA exerted by ball B on ball A. Therefore, mathematically, we can write FAB is equal to minus FBA, or MA multiplied by VA minus UA the whole upon T is equal to minus MB multiplied by VB minus UB the whole upon T, which gives MA UA plus MB UB is equal to MA VA plus MB VB. Now, MA UA plus MB UB denotes the momentum of balls A and B before the collision, and MA VA plus MB VB denotes the momentum of balls A and B after the collision. From the previous equation, we can observe that the momentum of the balls before collision is equal to the momentum of the balls after collision. That is, we can say that the momentum of the balls remains unchanged or conserved provided no other external unbalanced force acts on them. Hence, from this ideal collision experiment, we can state that the sum of momenta of two objects before collision is equal to the sum of momenta after collision, provided that no external unbalanced force acts on them. This is known as the law of conservation of momentum. An alternative statement for the given law can be stated as the total momentum of two objects remain unchanged or conserved during the collision. Let us now consider an example to understand the law of conservation of momentum better. Take the situation of firing a gun. Before the firing occurs, both the velocities of the gun and the bullet are equal to 0. After the bullet is fired from the gun, it moves in the forward direction with certain velocity. Now, according to the law of conservation, the total momenta of the objects before the firing should be equal to the total momenta of the objects after the firing. Hence, the sum of the momenta of the gun and the bullet after firing should be equal to 0. Then, if the bullet acquires a velocity in the forward direction, then the gun should acquire a velocity in the backward direction. This is observed by the recoil of the gun when the bullet is fired from it. Therefore, the law of conservation of momentum is verified in this case. Several other examples from our everyday life can be observed which follows the law of conservation of momentum. It is important to understand that all conservation laws such as conservation of momentum, energy, angular momentum, charge, etc. are considered to be fundamental laws of physics. These are defined on the basis of experiments and observations. However, we must remember that a conservation law cannot be proved. Any experiment whose result is in accordance with the statement of the law can verify the law but can never prove it. Whereas, if there exists even a single experiment whose result does not follow the statement of the law, it is enough to disprove the law. The law of conservation of momentum has also been deduced from several observations and experiments. It is interesting to know that even though the law was first stated nearly 3 centuries ago, still not a single situation has been observed that contradicts the law. In this video, we learned about the law of conservation of momentum.